All right, so today we are reacting copper to sulfate with some iron filings in a reaction that you're gonna identify what the type of reaction is. I've already weighed out my copper 2 sulfate. I've got about 3 grams, exactly 3.00 grams of copper 2 sulfate. I'm going to dissolve that in some water because the solids won't react just by themselves. So I'm gonna dissolve that in here. Oh. I'm going to turn on my hot plate. Okay. I'm going to add my stir bar because, you know, that's more fun than a glass stir rod. So let that stir to dissolve. My iron filings I have weighed out in my little muffin tin. Okay. It's a really easy reaction. You add some heat just to, one, dissolve the copper 2 sulfate. But also it just increases the rate of the reaction, right? Which we see a lot, adding heat as that little catalyst. So we're gonna do that. This whole setup is the after, where we need to isolate our product. So we're gonna make some solid copper, right? So you can think about what type of reaction that is when we're starting with copper 2 sulfate and iron, and we're ending up with copper and iron sulfate, okay? So because of that, it's kind of a solid, but it's a little wet. So we're gonna use this apparatus, which is a vacuum filter, okay? It's attached to a Buchner funnel, it's called. And so I'm gonna filter off the solid. I've already massed my beaker ahead of time. And so I know the mass of that, and so I can calculate what my final mass is. I'm also going to dry out the product. So that's where my trusty lighter and that comes in, and oh yeah, my Bunsen burner. All right, it's looking like that is pretty well dissolved. I'll stop the stir and check it. Yeah, looks pretty good. So I'm going to remove that stir bar for the reason that I don't want to get all the product gunk on the stir bar. Okay, all right, so I'm gonna keep the heat going, and I'm going to add the iron. Okay, I will get a glass stir rod. You can take a look at that, because I can stir it. And the glass stir rod's easy to clean. So this reaction doesn't take a super long time. Normally. I have, and my TAs have tested, all different sources of iron. And it seems like the powder tends to work the best. So let's see, we're looking for a color change in both the solid iron at the bottom as well as the solution. So we're gonna see if we can get that to happen. I did try this time to use a little less iron because I was finding my reaction wasn't going to completion. You all are going to be learning about that in stoichiometry and those, how important those proportions are. I don't know if you can see, but if we flip this around, you might be able to see that that iron, the powder in the bottom, the solid in the bottom, isn't quite that silver color, right? Make some observations about how that's changed. What color does it look like now? We're gonna pause the video and we'll come back after we see more of a change. All right, Cooper, it's my son Cooper. What changes did you notice?
It got a little bit more blurry at first, and now it's turning a little bit green, and I cannot see the iron anymore.
Yeah, so the
The
iron.
iron has turned like a weird color, like black, just full on black.
Black. We'll see what it looks like when we isolate it. But I would definitely agree. I agree that solution definitely turned. You were saying blurry, kind of cloudy. Yeah,
it's a
a little cloudy, and it's definitely way more green rather than this was kind of the color we started with of the copper sulfate. Yeah, it definitely is. All right, so we're gonna get ready here in a minute. If you want to just scooch over, but you can stay there. We're gonna use our fancy filter. So we're gonna turn this on. Now this works. This tube actually creates a vacuum to the flask. It's a sealed system, and so it's pulling air out of there. And so,
I see a change in the temperature. Or the iron.
be really careful because it is hot. We're gonna filter that solid off into our snuff funnel. And it's okay if I leave some because I'm actually going to heat the speaker again. So if we look in there, what color do you notice, Cooper? What color does that look like?
Brown, like dirt brown.
Kind of dirt brown, reddish.
Yeah. I would agree with that.
Maybe a little copperish color.
Yeah.
All right, so we can.
And now the water in there is blue.
Yeah, so the water, that filtered out all of the water, which is super cool. I guess I
Just open this.
I'm just removing the funnel, or the filter paper. So there was a piece of filter paper in here
Oh,
to trap the solid.
that is right.
And if we left it on there long enough, we could get the solid to fully dry. But think about, why would we want the solid to fully dry before, don't tell him, Cooper, but why would we want the solid to think about, why do we want the solid to fully dry before we take a final mass of our product? Because we're trying to figure out which product we make. Did we make, which proportions did we get for our products, okay, for the copper? So what is the balanced chemical equation for reacting copper sulfate with iron? We're dropping things all over the place. Okay, so now we got our stage 2 set up, and I need my Bunsen burner because I'm just gonna speed this along. All right, so you could totally do this on the hot plate too, but this will go faster. I'm trying to just dry out that water. You can see this gets super hot because we have metal out there, so you can see it get red.
Yeah, I can see
It's
the metal.
very
get
hot,
really
so we
red.
would not want to touch the metal.
You probably got that.
So that sizzling is just sizzling off the extra, the extra solution that was left. So I just want to get it till it's pretty well dry. So think about, why would we want it totally dry? What does it matter? Why can't we have a little bit of that in there when we mass out our product? So I'll crank this up a little bit. Notice we're using Pyrex glass, not Chymex, not, what is the other one? Bimex. None of these knockoffs. We want Pyrex because Pyrex is heat treated, so it should withstand hot temperatures. Now, there's always a breaking point, but if you use the knockoffs, you're going to be disappointed. Okay, we're going to pause the video again.